the science of time travel. Beyond sci-fi, imagine stepping into a machine, pressing a button, and suddenly you're 100 years into the future or the past. It sounds like something out of a Hollywood movie, but what if science says it might actually be possible? Time travel has fascinated humans for centuries, but it's always been just that, a fascination, until now. Today we explore the real science behind time travel. What do Einstein, wormholes, black holes, and quantum mechanics have to say about bending time, and if it is possible? What's stopping us? Let's go beyond fiction. This is the science of time travel. Why time travel isn't just sci-fi for decades. Time travel has been a playground for science fiction writers. From H.G. Wells' The Time Machine to Marvel's Avengers Endgame, the idea of moving freely through time captures our imagination. But real scientists are asking real questions. But Einstein blew that idea apart in the early 20th century with his theory of relativity. According to him, time can bend, it can stretch, can even slow down. Physicists aren't just ignoring the concept. They're building equations, running simulations, and exploring the cosmos in search of answers. Because, as it turns out, the laws of physics don't necessarily forbid time travel. They just make it ... really, really hard. Time is not what we thought it was. In the past, it was seen as a constant, like a train track, fixed, reliable, always moving forward. You'd essentially be traveling into the future. And that opens a door maybe not to DeLoreans or blue police boxers, but to a very real possibility that time travel might exist, even if we don't understand it yet. We just don't have the technology yet to build a ship that can go that fast. Einstein's time. Bending reality. Einstein's theory of special relativity introduced an idea that was as revolutionary as it was bizarre. That time is relative. Wormholes, or Einstein-Rosen bridges, are theoretical tunnels through space-time that could connect to distant points in the universe or even to different times. This has been proven, not just theorized, as astronauts who spend time in orbit age just a tiny bit slower than those on Earth. It's called time dilation. Instead of traveling across the surface, you jump from one point to another instantly. The challenge is making one stable enough for human travel. Most theories say they'd collapse instantly or require a substance called exotic matter to stay open. What does that mean? It means the faster you move through space, the slower you move through time. You might be able to travel not just across galaxies, but across centuries. In theory, if you were to travel at speeds close to the speed of light, say, in a spacecraft, you could experience just a few years while decades or even centuries pass back on Earth. So yes, forward time travel is technically possible. But what about going backward? Any attempt to do so will always result in events unfolding in a way that preserves consistency. So if you change something in the past, you're not altering your own timeline, you're creating a new one. That's where things get much trickier. Wormholes and shortcuts through time. Enter the wormhole, a concept first proposed in 1935 by Einstein and physicist Nathan Rosen. Now, your parent is never born. So, ... How were you able to go back in time in the first place? He has built small-scale experiments and believes that information might travel through time even if humans can. They're published in peer-reviewed journals backed by serious mathematics. Still, they're far from practical applications. Others warn of radiation and feedback loops that would destroy any traveler. Think of it like folding a piece of paper and poking a hole through it. Wormholes are a popular idea in science fiction, but they also exist in real physics equations. And exotic matter isn't something we've been able to create yet. But if it did exist, and if we could keep a wormhole open, the paradoxes that break the universe GPS satellites need constant time correction, because time moves differently for them than it does for us on Earth. Here's where things get weird and controversial. Let's say you go back in time. You meet your grandfather before he has children. You accidentally stop him from meeting your grandmother. The laws of physics don't outright forbid it, but the technical challenges are enormous. This is the grandfather paradox, and it's one of the biggest headaches in time travel theory. Some scientists say time travel to the past is impossible because of paradoxes like this. Others propose solutions. One idea is the multiverse theory. Every action creates a new parallel universe. Another concept is the Navikov self-consistency principle, which says events in time are fixed. You can't change the past. Maybe we're destined to move forward second by second, forever. Time might allow loops, but not chaos. The next great breakthrough could come from a mind just crazy enough to try. Is anyone trying this for real? You might be wondering, has anyone actually tried to build a time machine? Speaks to something deeply human. Our desire to rewrite the past, or skip ahead to a better future. Well, sort of. Russian physicist Sergei Krasnikov proposed the Krasnikov tube, a theoretical structure that could, in theory, allow for faster-than-light travel between 2 points, maybe even backwards in time. Physicist Ronald Mallet has also developed a time travel theory based on lasers creating rotating spacetime.
Ow.
These are not just fantasy. The energy requirements are enormous. Some estimates say you'd need more energy than the entire mass of Jupiter to create a stable wormhole. In short, we're nowhere near building a time machine. But science is taking the idea more seriously than ever. So, is time travel possible? In some ways, time travel is already happening. Particles like mu-Einstein relatives of electrons experience time differently when moving near light speed. The science is real. The effects are measurable. But when it comes to humans jumping through time like in the movies, we're still stuck in the present. And even if we could build a machine, would we dare use it? Would we trust someone to alter the timeline? Would you? Final thoughts? What time travel tells us about ourselves? The fascination with time travel is more than just curiosity. We want to fix mistakes, revisit lost loved ones, see what lies ahead. Time travel forces us to confront the nature of time itself, something we live through every second but barely understand. Maybe we'll never bend time like in the movies. But as long as we look to the stars and ask, what if? It's the science of time travel will keep pushing forward, and who knows? If time travel became possible, what would you do first? Change your past? See your future? Let us know in the comments below. And if you enjoyed this journey through space and time, don't forget to like, subscribe, and hit the notification bell, because the future is coming fast and you don't want to miss it.